In this video, I want to show that the infinite series with the expression n squared times 1/4 to the n, I want to use the ratio test to show that it converges, and then show that it converges to 20 over 27. So let a sub n be the expression n squared times 1/4 to the n. A sub n plus 1, we get n plus 1 squared, and 1/4 to the n plus 1. The ratio of a sub n plus 1 over a sub n, and then this is the same as n squared plus 2n plus 1, and then here we can split this up. This is 1/4 to the n times 1/4, and then we get n squared plus 2n plus 1 over n squared, and then 1/4 to the n and 1/4 to the n. These will get cancelled, and then what's left is just 1/4. And so the limit of the ratio a sub n plus 1 over a sub n as n approaches infinity will be the limit of this expression right here. And then this is a constant 1/4, so we can move it and place it in front of the limit. And then for this expression, we'll divide everything on the top by n squared, and then divide everything on the bottom by n squared. And then we'll get 1 plus 2 over n plus 1 over n squared, and then down here we get 1. As n approaches infinity, 2 over n approaches 0, 1 over n squared approaches 0. So we end up with just 1 over 1, and then 1/4 times 1 is just 1/4, which is less than 1. And therefore the series here converges by the ratio test. When recorded, the ratio test says that if the limit of a sub n plus 1 over a sub n as n approaches infinity, if this limit is less than 1, then the series converges. And now let's show that the series with the expression n squared, 1/4 to the n, show that it converges to 20 over 27. And then here are the terms. And so let's call this infinite sum right here. Let's call it S. And then here we have 1/4, and so I'm going to multiply S by 4, which is the reciprocal of this. And multiply this sum here by 4. Then we get 1 plus 4 over 4, 9 over 16, 16 over 64, and so on. 4S minus S, or this sum, infinite sum, minus this infinite sum. Right here we get 1, 4 over 4 minus 1 over 4 is 3 over 4. 9 over 16 minus 4 over 16 is 5 over 16, and so on. 3s minus 4s minus s is 3s. Here we get 1. And then this part here, we can write it as the sum with the expression 2n plus 1 over 4 to the n. And so notice when n is 1, we get 3 over 4. When n is 2, we get 5 over 16, and so on. And then the expression 2n plus 1 over 4 to the n, we can write it as 2n over 4 to the n plus 1 over 4 to the n. And then here we can move the 2 to the front of the summation sign right here. And now let's multiply everything by 1/3. So multiplying by 1/3, we get s, and here we get 1/3, and here we get 2/3, and then here we get 1/3. This infinite series right here, this is a geometric series, and the first term is 1/4. The common ratio is 1/4. And so it converges to to a dividing by 1 minus r, and so we get 1/4 over 1 minus 1/4. And this part here would be 1/3, and then the third times the third is just 1/9. And so the only thing left is just this series right here. And so now let's find the series with the expression n over n dividing by 4 to the n. And here are the terms of the series. And let's call this infinite sum, let's call it s sub 2. And then multiply s sub 2 by 4. Then we get 1 plus 2 over 4 plus 3 over 16 plus 4 over 64, and so on. 4s sub 2 minus s sub 2 is this infinite sum minus this infinite sum. We get 1, 2 over 4 minus 1 over 4 is 1 over 4. 3 over 16 minus 2 over 16 is 1 over 16, and so on. This for s sub 2 minus s sub 2 is 3s sub 2, and we get equal to 1. And then this part right here, we can rewrite this as the infinite sum with the expression 1 over 4 to the n, which is the same as 1/4 to the n. This is a geometric series. Once again, we saw this a few moments ago. This is a geometric series with the first term equal to 1/4, common ratio equal to 1/4, so it converges to 1/4 over 1 minus 1/4. So we get 1 plus 1/3, which is 4/3. Multiply both sides by 1/3, then we get s sub 2 is 4 over 9. And so in summary, the infinite series with the expression n squared times 1/4 to the n, it'd be 1/3 plus 2/3 times 4/9, and then plus 1/9, and then altogether is 20 over 27. And that's the end of the video.